I wanted to finish off our problem number 29 that we looked at in class. We were given a function f of x equals cosine of x plus 3x. And in part A, which we skipped over, we were asked to show that f has a differentiable inverse. So we wondered how to do it. The way that the pros do it is to take a look at the sign of the derivative. But to do that, we need a theorem that we're not quite prepared to prove yet, but will be very plausible to you because you know something about derivatives. I'm going to give you a plausibility argument at this time, and then we will do a formal proof when we have the machinery for it. And here's our theorem. If f prime of x is positive on the open interval a to b, or if f prime of x is all negative on the open interval a to b, and we call such functions monotonic, then f is 1 to 1, hence f has an inverse. Now, I'm just going to use a graph to make this plausible to you, and we're going to prove this result at a later time. Take a look at this graph here, and you know about derivatives that if f prime is greater than 0 on the open interval a to b, then that means that f is increasing. And because f is increasing, it's going to automatically pass our horizontal line test. That is, if x1 and x2 are distinct numbers, then they will produce distinct y values. Likewise, if my function has an always negative derivative on the interval a to b, made it kind of steep. It almost looks like the derivative is infinite. I didn't intend that. If the derivative is always negative, then the function will be always decreasing on the interval a to b. And therefore, once again, distinct x values will produce distinct y values. Our function will pass the horizontal line test. So that's the plausibility argument. And the theorem is delightfully easy to use. If we go back to our original function, to show that it has an inverse, we need only to look at the sign of the derivative. And f prime of x is equal to negative sine of x plus 3. And because sine x is trapped between negative 1 and 1, therefore, this derivative is always positive. And from that, I can immediately conclude that f has an inverse. I don't know what it is. I really don't. Because it's not possible to algebraically invert f of x. But I know that it has one. And we want to show that this inverse is differentiable, so we will actually calculate its derivative using the inverse function theorem. And once again, we do not know what the inverse is, so we're going to have to leave our derivative in the form 1 over negative sine of f inverse of x plus 3. And because negative sine of f inverse is going to be a continuous function trapped between negative 1 and 1, therefore the derivative is going to be trapped between 1/2 and 1/4 for all x. This has a value for all x. Hence, our function is invertible, and that inverse has a derivative. It is differentiable. And that's it. I'll see you on Monday.